Alhamdulillah Rabbil Alamin. Wassalatu wassalam ala Rasulillah sallallahu alayhi wa sallam. We're going to look at ionic bonding again. Now we'll be looking at the properties of ionic compounds, okay? The properties of ionic compounds, okay? Of ionic compounds. That means a compound that is formed from ionic bonding, okay? Notably sodium and chloride, okay? Because sodium and chlorine, yes, when they dissolve in, okay? Now, I explained about electrostatic forces within the molecule and electrostatic forces between the molecules, yes? I demonstrated that, yes? Now, the best way to do that, let's say, although this looks like a covalent bond, but let's say we have oxygen, okay, and sodium, okay, sodium, meaning here, this one giving one electron, giving one electron, okay? Okay? Now, this is, an electron is negative, sorry, positive, this is positive in this is two negative in it. The force that attract the positive and the negative together are called the intra, okay? The intramolecular in it. Now, if that, of course, in a compound, there are many molecules of the same compound, yes? You may have another sodium here with the same thing, positive, negative, 2 minus, another one here, okay? And many of them, maybe thousands and thousands of them, because it form a giant structure. Like, if you look at sodium, the structure of sodium, okay, is in the form of a lattice like this, like a box. I will show you the picture, okay? It's form of a lattice like this. So even here, it will be like that, even in the middle, it will be like that. Here, okay? Okay? Sodium, positive, negative, negative, positive, negative. It will be like that, yeah? Let me show you the structure to the camera, because I can't draw it properly. Okay? Mustafa, can you bring the camera, please? See? Can you see? Okay? You can see the structure of sodium chloride, common salt. Positive, negative, positive, negative. They arrange in like that form. So each positive attracting to a negative, yes? So the bond within the atom, the molecule itself, like sodium oxide or sodium hydrogen, the bonding within this is called inside. Okay? But between each red and blue and another red and blue, you can see it here. Okay? Positive, negative, positive, negative. The forces between each molecule is called intermolecular forces, okay? Or intermolecular electrostatic forces, okay? So this is what happens, and that is what is responsible for most of the properties of sodium chloride or ionic bonds, ionic compounds, okay? Ionic compounds. And we are going to look at them when we do covalent bonding. We're going to look at them in form of T-shape, okay? T-shape, yeah? The properties of that, and they look very familiar to it. They're the opposite, yes? First of all, ionic compounds are mostly solid, yeah? Mostly solid, in it. Okay? Now, mostly solid. Number two, they dissolve in water. Very important. In water, yes? In water, yes, forming a positive and negative ions. Okay? So let's say if you have water, a basin of water like this. Okay? And you put in salt, which is sodium chloride. Okay? In the water, what you will get will be not sodium and chloride joined together like this, with minus plus 1 minus 1 is equal to 0 in it. So no charge, but they are going to dissolve in water, forming sodium and chlorine ions in it. So you have positive and negative ion inside the water. Okay? So that's why they dissolve in water. Okay? As opposed to covalent compound, they don't dissolve in water because they don't form ions. Since they don't form ions, since they form ions, that gives the third one. Okay? Conduct electricity. Electricity. Also mean they conduct heat, yes? Conduct heat. In the exam, you have to know these things. These are the chemical characteristics, okay? Not the physical. The physical is what you can see, feel, and taste, okay? The chemical characteristics are chemical reactions, okay, that they undergo, okay? So they can conduct electricity, and two, because of what I told you, high melting and boiling points. And I explain this by means of electrode. Okay, you may have 600 degrees Celsius. As opposed to water that we will drink has a freezing point of 0 and boiling point of 100 degrees Celsius, okay? Now, what is a boiling point and what is a freezing point? The boiling point is at a temperature at which 1 liter or 1 decimeter cube of a liquid turned into gas. The time it changed state from liquid to gas, okay? Because of high temperature being applied to it, okay? That is called the boiling point. The freezing point is at which it changed from liquid back to solid. Okay? So you have to get that right, okay? Melting point and freezing point. Melting point and boiling point basically the same, okay? So solid, okay, to gas or liquid to gas will be the boiling point in it. But from gas or liquid, meaning freezing in it, back to solid will be the freezing point, okay? Freezing point. The camera should show this. The camera should show this, okay? So from solid state or liquid state to gaseous state will be the boiling point. As for water, it's 100 degrees centigrade or 100 degrees Celsius. But from gas or from liquid back to solid is called the freezing point. And for water is 0 degrees centigrade, okay? 0 degrees for water. Do you get it? Yeah. So you have to understand these things, yes? So as at now, that's what we look at the properties of ionic compound. And all the ionic compounds share these properties. All the ionic compounds share these properties, yes? So therefore, as far as conducting heat and electricity is concerned, they have to be in liquid state, okay? In liquid state, not in solid state. In a solid state, there is no ions. In liquid state, they dissolve in to form, I show you, ions. And these ions, the charge that conduct electricity, okay? They have to be in liquid or in molten state, okay? When heated, yeah, molten state. Or you can even call it sometimes they call liquid as aqueous, yeah? Something like aqueous, not very different, aqueous state, okay? That's why when they add the compound, sodium, they put aqueous down. Mean it is in an aqueous state. Like iron, when you melt iron, you understand? Apply so much heat, you melt it, it's in a molten form, innit? Yeah. But when it dissolves in water or another solvent, it's called a liquid state, okay? Aqueous is between them. Now this is basically the properties of ionic compounds. And this is very, very important. It's very important for you to know this. In exam, they can give you melting and boiling points, yes? Compound X, Y, Z. Melting point, 500 degrees centigrade, 400 degrees centigrade, 300 degrees centigrade. Okay? And centigrade, okay? Or electrostatic forces, 600, okay, 500, 400, electrostatic forces. Why is this one has melting point? Because of the electrostatic forces, okay? Yes, and what compounds are they? Likely, they may be ionic compounds, okay? Because they have very high boiling and melting points. Some covalent compound will do, like polymers and giant covalent compounds, okay? They do have high boiling points, but not as high as ionic compounds, okay? So basically, the reason why ionic compounds, when they dissolve in water, they conduct electricity is demonstrated by electrolysis, yes? We have two electrodes, positive and negative, joined by a wire, and electricity is applied, okay? Yes. I think the positive is the anode, negative one. The cathode is the positive one. I hope I didn't explain it, yeah? Then this molten solution, let's say, is sodium chloride, yes? But the sodium will be in liquid state in it. There will be ions in it. Okay. So this is called, sorry, let me do that with another pen. Okay. Liquid here. And the name of the liquid is called electrolyte. It is electrolyte. This is the solution which has been, okay, electrolysis applied. Solution. The solution is sodium chloride in it. It's called the electrolyte. This is called the positive cathode and the negative anode. So basically what happens is, when electricity is applied, these things become vibrating. So the negative will go to the positive anode in it, chlorine in it. So when they go to it, they receive electron in it. These ones will go attracted to that one in it. Yes. Guess what? Chlorine, because it's negative, it goes to the negative anode in it. These things are called the electrode. Yes, they are called electrolyte and electrode in it. They are called electron, the positive or negative. If you look at a battery, at the top is positive and negative, and within this there is a molten. That's a molten electrolyte. Okay, the dark thing inside the battery is electrolyte. When you apply electricity, it can generate electricity. Do you understand? Now, guess what happened here? Chlorine goes to the cathode, and what happened? It receives electron in it. It's chlorine minus in the solution because it dissolves. It will receive an electron. It becomes chlorine gas. So when you put a tube here, connected to this, chlorine gas come out. You understand? But it will be that in it. But let's say you have two chlorine, plus 2 electron will give you chlorine gas. That happens at the cathode. You understand? But the sodium is dissolved in water. So sodium will, in the water also, you'll have hydrogen atoms, hydrogen ions. I didn't show that. You'll also have hydrogen atom because it is dissolved in water in it, and OH minus ions as well. Comes an OH minus. From here, all the H plus will come here in it. Then you have a H plus, okay? H plus plus E or 2H give you hydrogen gas. Okay? Hydrogen gas, 2E. Sorry, 2E. Okay? Now, but what is left is sodium ions and OH minus ions. So that is sodium hydroxide. So if you test this compound after electrolysis, there will be sodium hydroxide in the left. Because chlorine is gone out as a gas, hydrogen is gone out as a gas. What's left is sodium ions and OH minus ions, okay? And they form sodium hydroxide. And that's all about electrolysis. The reason why I give you the 9 and we are doing electrolysis to show you how ionic compounds conduct electricity. Okay, do you feel me? Yes. I would try to demonstrate to you how they conduct electricity because they can dissolve in water and form ions. Covalent compound will not do that. They will not dissolve in water to form ions, so they cannot conduct heat, they cannot conduct electricity, except for graphite and what's the other one? Graphene, okay?
No, graphene doesn't go to the local electrons.
Oh, the local, okay, yeah, forget about it. You're right. Okay. So, this is how it conducts electricity, yes? And we have finished that topic. Which topic is left now? I've shown you about the giant ionic compounds. We saw the picture of how they're structured and how the positive and negative ions are left out and they can conduct electricity, yes? Yeah, we saw that is the last topic on ionic compounds, yes? And ionic compound basically, let us wrap up. Ionic compound basically are reactions between a metal and a non-metal in it, and it involves donation of electrons as opposed to sharing of electrons, which are covalent compounds, okay? Now let's look at the examiner's book.
No, what metallic bonding?
We'll do metallic bonding, okay? Metallic bonding is the metal itself, only the metals, yeah? You understand that the positive and negative charges in that of the nucleus and that of the electrons, okay? So, ionic compounds all have high melting point and high boiling points due to many strong bonds between the ions, okay? This is called intermolecular forces. It takes a lot of energy to overcome this attraction. When they are solid, the ions are held in a place, so the compounds can't conduct electricity. But when the ionic compound melt, the ions are free to move, okay? And they carry electric current. As I draw it here, when they are inside the solution, they can move. They're in a state of, okay, entropy. So that's disturbance, yeah? Yeah. That's why they can conduct electricity, yes? Ionic compound also dissolve easily in water. The ions separate and are free to move in a solution. They all carry electric current, okay? That's what it's saying. And I explained that to you. When you dissolve the ionic compound in water, they all separate into their various ions and they move in it, okay? When they move, they can conduct electricity, okay? That is the technology behind the battery. Okay, this ordinary battery we use to compound. How many minutes? We're not finished yet. Now we're going to look at covalent bonding, and our next one is 11 o'clock. Huh? Our next one we will look at covalent bonding in the light of what we have learned in it. Okay. Now covalent bonding. Covalent bonding involves two reactions between two non-metals, yes? Okay, especially group 6 and 7, 5, 6 and 7, okay? And since, you have to write it down, since each atom has a near group 0 configuration, yes? Configuration, yes? Okay? They share electrons. They share electrons, okay? In the outermost cell. In the outermost cell. So, basically, let's look at oxygen. Oxygen is in group 6 in it. Group 6. Okay? It's 2, 6. So oxygen has 6 in the outermost cell. Now, if it's going to react with another oxygen, which is also 2, 6, because this is more than 5, okay, it's very close to group 4, group 0 in it. It's only 2 less than 8 in it. So they form covalent bonds, okay, and that involving share of electrons, okay. If you look at hydrogen, H2, hydrogen has 1 electron in the outermost cell, okay. For hydrogen gas, this is called a hydrogen molecule. For hydrogen gas to form, they have to share electrons, okay. Hydrogen in it, and hydrogen atom is like this. Hydrogen, only one electron in it, okay. So this hydrogen will have 1 in its outermost cell, okay. Look at the way I'm drawing it. This hydrogen will have, okay. So basically 2 hydrogen coming together. This plus doesn't mean, please, the plus doesn't mean, it doesn't mean ionic bonding, but this one is reacting with this. Both have 1 electron in its outermost cell. They behave just like a metal in it, okay? But it's not a metal. They form a covalent bond. This is called a covalent bond, okay? Covalent bond, which is sharing of electrons. Sharing of electrons. Now, you should tell me, because the first case cell can take a maximum of how many electrons? 2. Does it not appear that this has 2? Yes, it appears it has 2. This one appears as 2. So they all conform to group 0, isn't it? Because group 0, one of them, I think helium, has 2 electrons in the outermost cell. Okay? So the total number of electrons in each outermost cell, that is the first cell, K cell, is 2. So they all attain noble gas configuration now. Okay, all of them. This is called covalent bonding. Now, the covalent bonding, we have to show covalent bonding between more of these things, yes? There's one which is very difficult to show. That one is nitrogen, N2, okay? Now let's look at oxygen. This is, okay, covalent bond. We are trying to show simple molecular substances, yes? Okay, the one we have shown is hydrogen, okay, and we have not shown oxygen, yeah? Let's look at the oxygen molecule, okay? Oxygen is 2, 6. We have done that before in it. So let's say we have 2 oxygen. Okay, we saw only the outer cells when we are doing this, yes? When we are doing our dot and cross, or our sharing of electrons, we saw only the outermost cell, okay? So, the oxygen will have 6 here. Look at it. Okay? Okay? Also, we have 6 here. Do you get it? Now, you have to be very careful how you do it. Okay? You have to be very, very careful how you do it. Now, the examiner wants you to show how oxygen molecule look like. Okay? Now, don't confuse this with ionic bonding. I just want to show you that one oxygen is reacting with another oxygen in it. So the covalent bond structure will be like this. Okay? They both have 2 in the atomos cell. So where they share, okay, you will have so in the exam, be careful of this, how you do this, okay? So they're sharing how many electrons? 4 electrons in it. They are sharing that. So the rest will be for this one, sorry. O, it will be like this. Sorry. I'm getting this mixed up. Okay. This will be the. So it has 1, 2, 3, 4, 5, 6, 7, 8 in it. Yeah. Now this other one also will be like the same. Okay, that's another O. So this is the how to depict a covalent bond. The sharing electron in the atomos cell. So it appears to have 8 electrons in the atomos cell. Okay, for the noble gas configuration. This is called an oxygen molecule. The covalent bonding. Yes, oxygen molecule. Okay, you can do this. This is one of the way of representing it. Okay, and there's another way you can demonstrate it by doing only looking at only the thingy, the dots. Okay, only the dots. So we have one oxygen here, one oxygen here. Okay, they share. Okay. Okay, this one. Okay, meaning they have, you don't need to put the line, okay? You mean they are sharing electrons, yes? This is one oxygen, this is one oxygen. Now let's look at one critical one they saw. 30 minutes. We want to show methane. Methane, ammonia, what's it? Ammonia, okay? No, ammonia. Ammonia. I don't want it to go for 30 minutes. One famous covalent compound is ammonia, NH3. Okay, 29 now, yes? We have our nitrogen, okay? Nitrogen is 2, 5 in it, and hydrogen is 1 in it. Okay, 1 electron. So nitrogen has 5 electrons in its outermost shell. Okay, so we will have 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here. Hydrogen, hydrogen, hydrogen. And all these hydrogen, they'll have their own electrons, okay? They have their 1 electron here in it. 1 electron here, sharing, okay? 1 electron here, sharing. So basically, how our dot will look like is, we have X and 0, hydrogen, okay? X and hydrogen, and 0 hydrogen, then XX, nitrogen. Okay, so you can show it that way, you can show it that way, innit? Yes. So this compound look like this, nitrogen, so it's NH3. Remember, nitrogen is non-metal, hydrogen is a non-metal. So the difference between two non-metal is called ionic bonding, okay? Sorry, covalent bonding. Do you see? The examiner would ask you to show the electronic structure of the gross and dot diagram of ammonia, okay? This is called ammonia, okay? Ammonia. And it's used as fertilizer, okay? Ammonium sulfide or ammonium nitrate, okay? So used as fertilizer. 30 minutes. 31. Okay. The last one we'll show, you can try fluorine and fluorine, iodine and iodine, okay? Chlorine and chlorine. You can try it by yourself, but let's look at another well-known compound called methane. Methane is the gas you see in these gas tanks, yes? CH4. One carbon is 624, okay? Carbon is equal to 2, 4, and hydrogen is equal to 1, meaning electrons configuration, yes? So you have your big carbon with 4 electrons in its outermost shell. Sorry. Carbon. Okay, so one hydrogen can come here. One hydrogen can come here. One hydrogen can come here. And one hydrogen can come here. Hydrogen, hydrogen, hydrogen. They'll be sharing electrons in it. Okay, so this look like this. Carbon, okay? X0, okay? And this is hydrogen, hydrogen, hydrogen. Hence the compound look like this. It's called methane, and they are called hydrocarbon. You know, you heard about petroleum. When you distillation of petroleum, one of the first gases that comes out is methane. Okay, because I have a very low boiling point. Okay, so these are the structures of covalent compounds. Okay, now what we have to learn, why they have low boiling point as opposed to ionic compounds. Okay, this is because although there is inside, okay, there is strong, so this is hydrogen, okay, strong electrostatic forces, yes, electrostatic, okay, forces, called molecular forces, yes. But between the next methane, okay, as I tell you, you have CH4, another CH4, another CH4. These forces between the molecules, yes? Okay? The forces between the molecules, okay? Let me show this by, okay? These forces are called intermolecular forces or intermolecular forces. These are very weak, okay? They are weak compared to ionic, yeah? Are very weak. Compared to ionic compound, yes? Compared to ionic compounds. You have to show this, Akim. Compared to ionic compounds. That's why, therefore, Let's come here. Therefore, they have low melting, and boiling points, yes? Low melting and boiling points. Compared to ionic compounds, yes? The only reason why is low melting and boiling, yes? Okay, you get that? That is why they have low melting and boiling point compared to ionic compounds. Now, I don't want this video to go long. 35 minutes, okay, very long. Quickly, let's finish this. That's why, because their properties are, most of them, there are some exceptions, yes? Most are liquid and gases, yes? Liquid and gases. There are exceptions, yes? Higher chain hydrocarbons, yes? Hydrocarbons. With higher molecules, yes? And they don't dissolve water, yes? They do not dissolve in water. Okay? In water to form ions. So therefore, they don't conduct electricity. They don't normally, let me qualify that, yes? Conduct electricity. They don't conduct electricity except for graphite. Except for graphite. We look at the graphite in our next one, yes? I don't want to go into because the video is going to be very big, yes? Because graphite, the structure of the graphite, there are some stray electrons, yes, that will conduct electricity. But the rest of the giant hydrocarbons, sorry, the giant covalent compounds like diamond, silicon, graphene, graphite, they don't conduct electricity.
Graphite does.
Diamond, except graphite, I said. Okay? Diamond is one of the precious metals. It's only carbon. Okay? It's only carbon. Okay. So, that means you can make diamond, isn't it? Yeah. We can start tomorrow. Okay.
Put your carbon in high pressure.
Yeah. We put carbon on the extreme high pressure and over a long period of time, innit? You can make a diamond. But maybe the pressure will apply and they will not even worth the amount. Yes? So they have liquid, they don't conduct electricity, they don't dissolve water, they have low boiling point, yes? They have low boiling and melting point, yeah? All this is in contradistinction to, you know the word called distinction, yes?
Opposite to.
Yeah. In comparison, yes? Distinction to ionic compounds, okay? Ionic compounds. Okay? All this I'm saying is in contradistinction to ionic compounds, okay? So, basically, they look like the opposite of the ionic compounds, okay? They look like the opposite of ionic compounds. Most of them are liquid and gases, because they are group 7. So group 5, 6, and 7, one is nitrogen, oxygen here, chlorine here. Now, if you see them in fluorine, yes, fluorine first, yes. If you look at the exam or in the reactions, they don't say one element of ICEP. You say N2O2 chlorine 2 mean a chlorine molecule, but with a covalent bonding. That's right. Okay, that's what they are, gases. Even hydrogen, our Mr. Hydrogen, H2. They are all gases. Fluorine, gas. Then iodine, liquid. Okay, bromine,